Hello, today we're talking about legacy backup infrastructure transformation. This is a solution provided by Index Engines. It supports a number of different components to managing backup infrastructure, including catalog management and legacy data migration. Index Engines, we are a software company. We provide enterprise data governance solutions. A number of key aspects to our technology are very unique in the marketplace. It is designed for large-scale data environments. We work with some of the largest organizations in the globe that manage data in petabytes, so it's a very scalable solution. It's also very unique in that it's the only solution that supports both primary storage as well as backup data sources. Today, we're going to be speaking mostly about backup data sources. Our customers are using Index Engines to help find, manage, and govern this data based on policies. So it's a lot about long-term retention objectives, regulatory requirements, and really supporting access and management of key corporate records. We have a number of key partners in the business. They're focused into different spaces. On the IT side, Dell EMC is a very strong and strategic partner for Index Engines. On the governance side, we have a number of advisory partners like Ernst & Young, FTI, and others that provide advisory services around unstructured corporate data and email. We have clients globally from the largest financial services firms, healthcare organizations, manufacturing firms, pharmaceutical firms globally use Index Engines to help manage corporate records. So why transform your legacy backup environment? And we define legacy backup environment as non-production environments, those backup environments that are kept live and kept active to maintain access to legacy data. Why do you have these these environments? Really, it's through acquisitions or mergers. So if you merge or acquire another company, you acquire your backup environment. It's probably a different backup software or backup solution or backup strategy. Also, we work with customers that have changed to new backup vendors. So changing from an IBM or Veritas environment to a Dell EMC environment, for example, leaves you with a legacy backup environment. So why care about that stuff, that data? It's really the requirement to maintain a legacy backup museum for ongoing access. If you don't have any requirement to maintain access to that data for regulatory, legal hold, long-term retention requirements, then it's not really a problem. You can age that data out and retire it. If you do have 5, 10, 20, 30 plus years requirement to maintain access to that data, you really need to look at that approach, because that data is going to age and become more complicated to get access to. And also there's a risk associated with the use of legacy backup tapes for long-term retention. You can't really manage it. You don't know what's there. You can't apply retention policies. You can't support personal data management or privacy data management. So it's not governance ready, and it's really becoming a problem for large global organizations. So by maintaining a legacy tape museum is the environment you need to maintain in order to support access to this legacy content. It's more than just the offsite tape storage. A lot of organizations think, they spend pennies per month per tape to store it in a salt mine somewhere, but that's really just the tip of the iceberg. There's a lot of other expense associated with storing this legacy data. The backup software maintenance, so if it's non-production software and you need to maintain it in order to maintain access to this data, that could be significant expense. It could be hundreds of thousands of dollars, and it could be even more for larger environments. So the old tape library maintenance, thousands of dollars a month as you get some old LTO libraries, as well as the infrastructure like backup media servers. We have clients that are doing NDMP backups and need to maintain the NDMP servers for restoration. Like I said, the offsite tape storage is a small number, but it adds up. Tape management expenses, retrieving data, tapes back and forth from offsite storage and managing them can be significantly expensive. Data center resources, the staff you need in order to support management and access to this data. A lot of companies need to keep their staff educated and up to speed on how to manipulate and operate the backup software, especially something more complicated like TSM. It can get very expensive to keep those staffing resources in-house. So that's if you're doing the restoration yourself. Without the Legacy Tape Museum, you'll need to use outside consulting services. And I've seen, thousands or tens or hundreds of thousands per tape to do restoration by some of the third-party restoration services out there. So it can be very expensive. So either way, it's really not a best practice to maintain that data in offline storage on tape. It's something that really needs to change, especially with today's governance regulations that are popping up. So if you look at some of the advice from thought leaders like Gartner, one of their papers, one that just was published in October of 2017, they talk about some of these new regulations, specifically the General Data Protection Regulation, or GDPR, which is an EU regulation about personal data management. It affects not only EU organizations, but businesses, companies that do business in the EU, whether they're located in the US or throughout the globe. If they have EU-based customers, this will impact them. And Gartner, in this paper, talks about a number of different GDPR or governance readiness initiatives, but specifically to backup data, they talk about the risk. So if you read this quote, it says that enterprises often engage in long-term retention of backup to the point where data is unrecoverable or unretrievable in any meaningful way. So that includes, a 10-year-old TSM tape when you've migrated to Networker, for example, as your backup strategy. How are you going to maintain access to that as the libraries age and the tapes age and the software ages? But Gartner goes on to say even further, says, thus tapes really serve no business or operational purpose, but creates a potential hazard to GDPR compliance. A very bold and strong statement from Gartner, but they know that with this new regulation, personal data is sitting on those tapes. Those tapes are long-term retention archives, and the regulation is going to cover those archives. And if you do happen to go back to some of those old tapes and restore the data back online, you're restoring a lot of personal data back into your data center, which will really violate a lot of the policies and the efforts that you put in place to support things like the GDPR regulation. So let's talk about index engines. It's really a fundamentally different approach. Index engines have spent many years engineering access to these proprietary backup formats to provide access to the data that exists inside these containers. So index engines has also eliminated the requirement for the original backup software. You don't really need any of the backup software to get access to these backup tape data. Index engines can do that directly at a more intelligent and cost-effective approach. There's really three components to what index engines provides. The first one is backup catalog management. And a lot of customers just deployed this solution. And this is a low-cost alternative to maintaining the legacy backup software. And it's typically cost is a driving factor. It's typically 10 to 20% the cost of maintaining, for example, an IBM TSM or a Veritas Net Backup environment. And what this is the ability for index engines to ingest the legacy backup catalog and to manage the catalog going forward. It provides as much, if not more, functionality than the catalog provides in terms of search and reporting of the backup data. So a lot of customers just do this to control costs or implement this catalog management solution just to retire legacy backup software. And these are customers that have maybe shorter retention policies that really don't go back to tape that often, but need insurance to be able to get access to them, is they could use this to ensure access and ongoing access while eliminating the need for the original backup software. The next component is ad hoc restores. So throughout the year, clients may have eDiscovery or legal or compliance requests to restore files or email or mailboxes from tape. Index engines can manage that directly, again, without the original backup software. So that provides access to tape data, typically for clients that go to tape a couple times a year. If you're going to tape frequently, or if you're worried about the risk associated with what exists on the tape, or if you've got things like the GDPR regulation where you need to manage personal data more proactively, there's really backup data to cloud migration, which is looking at what exists on these tapes, doing an assessment and analysis, and really pulling the data required from tape for long-term retention. And this is typically far less than 5% of what exists on tape has long-term retention requirements. So it's the ability to selectively find that data and migrate it to cloud or to disk for long-term retention where it can be managed more effectively. So these are really the key solutions that Ingestion offers, which we will talk about in more depth. So a few case studies, some Ingestion clients that are using the technology. The first one here is the catalog management. This is a European energy company that was really consolidating a number of data centers, and they were shutting down data centers in 2 European countries. They had about 30,000 virtual tapes that were in TSM and net backup formats. So the ability here to consolidate this data into a single unified catalog was appealing. So they ingested the catalogs into Ingestion, and Ingestion provides the search and access to those 30,000 virtual tapes going forward. And that was a great consolidation and cost savings project. The second is Ad Hoc Restores. This is a global bank. This is really a Fortune 500 organization that is providing restoration from tape across the globe in many different data centers. The challenge they had is they had a lot of different backup formats, from Backup Exec, Data Protector, ArcServe, TSM, Networker, as well as NDMP backups. So it was complex. They needed all those resources, all that software, all the staff that understands the software to remain in place to do those restorations. They standardized on Ingestion as a single solution to do restoration, which really improved their time to data and significantly reduced their costs of getting access to that content. So that was Ad Hoc Restores. The third one is data migration. This is a global financial services firm where they migrated 14,000 mailboxes from 200,000 tapes. They were concerned about the risk and the exposure of that content existing on the tapes. They migrated it to a legal hold archive. This is an online archive. It really transformed their legal hold process and eliminated tapes from their infrastructure, from their long-term retention strategy. So three different use cases of the Ingestion technology, 3 different clients that are using Ingestion to support regulatory and legal hold requirements going forward. So let's look at the workflow and how Ingestion is deployed in the data center. There's really 3 components of what I mentioned earlier. One is the catalog management you see in the green section here, which is really the ability to manage catalogs. The second component is Ad Hoc Restores, to be ability to scan and index the content of what exists on tape and make it searchable so you could access individual files or emails. And the third component is migration, to really classify and develop a migration strategy, migrate the data of value either to disk or to cloud targets, and then manage it going forward in a long-term retention archive. So those are the components. It's really from a very light touch using Ingestion to a much deeper touch. And let's go into a little bit more detail here. The first phase is ingestion. So you can see there in the screenshot that is a demonstration of a number of different backup applications being ingested. If you look closely, you'll see it's ArcServe and Net Backup. And there's a number of search tools to search the catalog metadata and filter it by backup host types like Exchange or Lotus or Oracle or Windows, by date, by backup hosts specifically, backup date ranges, backup sets, and so on. So the ability to ingest is really the ability to connect to an active media server and ingest the catalog metadata. It's a very simple process, very easy to do. It captures not only the backup policies, but the backup properties as well. Allows you to report on all the catalog metadata, search and find relevant backup sets and barcodes. This process is done without even touching any of the tapes. This is done just through connection to a active backup media server. Simple process. We've done this at large environments, distributed environments that have multiple media servers, single environments, and so on. So the supported formats here for catalog ingestion are Net Backup, TSM, Commvault, Networker. Again, direct connection to the media server, and the catalog metadata is ingested. This allows you to retire these backup software applications. From this point going forward, you no longer need the backup software running in the data center. Ingestion will provide your management and access to that data. The other common formats that exist out there, we do not support the ingestion, but by scanning the tapes, you can rebuild the catalog. And typically those backup applications are used in smaller environments, so that's a very cost-effective and easy solution. So for something like Backup Exec, UltraBack, Data Protect, or ArcServe, those tapes would need to be loaded into a library, and IndexEngines can scan, index, and restore data as required from those tapes without the need to ingest the catalog. So IndexEngines supports all common backup formats. The ingestion here is really contained to these specific formats here with the logos on the right. So if you take a look at some of the catalog retirement, the TCO, the total cost of ownership, you know, it really has to do with a lot of the data center resources required to maintain the legacy tape museum. But a lot of the cost is associated with just really the software maintenance. And if you look at some of those IndexEngines clients listed there, you can see that the IndexEngines price to manage the catalog going forward is typically anywhere from 10 to 20% of what the client was paying for the backup software maintenance, as well as the infrastructure required to keep that software up and running. So you can see from large environments, you know, where it's multi-million-dollar annual costs for things like TSM or Net Backup, IndexEngines is a small percentage of that. For something like Lear Corporation, which is a smaller environment, IndexEngines was a very small purchase to be able to retire nearly $500K of software maintenance and infrastructure. So the cost savings is pretty obvious. And if you're just looking at eliminating that maintenance fee, IndexEngines is a great solution. The catalog management solution is great to accomplish that. The next component is reporting. Like I said, once the catalog metadata is ingested, you can filter, and you see in the screenshot, some of the filtering capabilities by backup agents, dates, locations, hosts, other properties, to be able to profile the data. You can look at incremental backups versus full backups, and so on. This is really looking more deeply at the catalog metadata and analyzing it. So if you just wanted to find all backups that were Exchange email backups, you can find those and filter down to those. Some of the backup software like Net Backup has file listings. You can look at file extensions, file size, modified times, very rich metadata that exists in the catalog that can be used for reporting. And you can search and find data or tapes or backup images or backup sets that need to be retrieved for restoration. So at this point, again, IndexEngines has not touched any of the tapes. This allows you to search the catalog to really determine which tapes need to be retrieved from offsite storage or from wherever they are in a storage locker somewhere, to be able to be retrieved so they can be scanned by IndexEngines, and by scanning the tapes that provides access to the data. So the reporting, very rich, very comprehensive. Many customers say the reporting within IndexEngines is equal to, if not greater than, what is provided with the original backup software. The next phase is indexing. So this is where IndexEngines does scan the tapes. So by scanning the tapes, it makes them fully indexed, either at a metadata or a full content level. And that allows detailed search for data for restoration. Again, without the need for the original backup software, you can see the tapes can be quickly scanned to be able to enable search for keywords, search for patterns like PII or personal data. If it's a full content, if it's not full content and metadata, you can find mailboxes or PSTs or specific files based on file name or location or date to be able to restore them. And at this point, once the tapes are indexed, they can be, data can be searched, previewed, and then accessed, which I'll talk about next. But this is really only, typically will be a subset of your total tape population. If you have a universe of 10 or 20,000 tapes, you're not really going to end up scanning them all, indexing them all. You really want to index the ones that have data of value, which could be the full backups versus the incrementals or certain date ranges and so on. The next phase is access. So now you can search, you can see this screenshot of the search interface to be able to search and find data. So if you have individual ad hoc requests for data from tape, such as eDiscovery requests and so on, you can use this to get access to that data. And this, again, without the original backup software, find individual mailboxes or files search and find them, and then restore them back to disk or restore them to a cloud target, your choice. But this allows you to continue to use tapes for long-term retention, but access the data as required off of tape when needed. So from that component, those first four sections really provide the standard access or standard management that you have today, the ability to manage the catalog and provide individual access as you need it. So that's typically what customers are doing today with either their legacy tape museums or using third-party restoration providers. But using index engines, you could replace those environments and still provide the same level of access, only more cost-effective. If you do have serious long-term retention requirements or regulatory requirements, like for personal data, or you want to manage the risk of the content that exists on tape, or some customers use index engines to find and manage old intellectual property that may have value, you really want to go into the last component here, which is really to classify the data and to use some of the reporting capability, as you see there in a screenshot, to really understand what data has value for the business or is required for long-term retention. And that typically is a small subset of what exists on tape, typically less than 5%. So finding that data of value and being able to tag it for long-term retention. So you can use the reporting, it's dynamic reporting for easy visual analysis, get detailed report on file and email metadata, report by file type, dates, locations, and basically classify and tag the data to determine what you need for migration. So this is really done a lot in collaboration with the records or the legal or compliance team to really help them view and visualize what exists on these old legacy tapes and determine what's required. A lot of times it's really email for the past 7 or 10 years, or specific users, content, files for X years by department, and so on. So I mean, there's different classification or migration policies. So here's an example of some of the workflow that we typically see. But if you understand the intelligence of index engines, is that you can really leave behind a lot of aged and useless data. And if you look at the reverse pyramid there, typically by filtering out the redundant content. So if you're doing using NetBackup, for example, and you're doing weekly fulls, there's a lot of redundancy in those tapes. A lot of the content is highly duplicative and really can be filtered out. Index engines create the document signature of files and email, so that you can just say, just only show me unique content. I really don't want to even care about the redundant content. Let's just work with the unique files and email. You could also look at data that's aged out outside of retention policy and say, I want to filter data by only content from the last 7 years, for example. You can also ignore types of files. For example, many clients just leave databases back on tape. Why would you want to restore a 10-year-old Oracle database? It really has no value. So leave that back on tape, such as log files as well, other useless data types. And then you get down to the relevant files and emails required for long-term retention. So that's a typical data classification and culling process that you would go through to understand what has value for migration. So if you look here on the left, there's a couple of different strategies that our customers look at. So if you really don't want to make any decisions about the data, which is probably the least efficient process, but it happens, you could say, I just want a unique copy of everything on tape. So that's using, just really looking at the first phase of this reverse pyramid and saying, just eliminate the redundant data and give me a unique copy of everything that exists, or a single instance from tape. So you're going to move a lot of data from tape. There's just no way around that. But that's really the least amount of culling that can happen. The second example there is a lightly culled environment. Say I just want everything for the past 7 years, for example, that has been created the past 7 years, and that's it. Or you can go heavily and cull it and say I only want email or specific file types or specific users for the past X years, for example. But typically, you're going to leave as much as 95% of data on tape. It won't be migrated because it's either redundant or it has no value. So the more that you can classify and manage it before you move anything from tape, the more efficient the process will be. So the next step is migration. So this is really moving the data from tape at this point. So as you classify it within the interface, there is built-in migration. It's a defensible process that maintains all the metadata and make sure it is accurate, so we don't strip out owners or access dates or things like that other tools do. But you can migrate the data directly within the user interface. Data can be migrated either to an NFS or cloud target using S3. It's directly extracted, and all the metadata properties remain intact, as I said. And it's really migrated to a single instance archive. The Index Engine platform provides this archive repository that'll manage this long-term retention data. It maintains the searchability, it maintains the metadata reliability, and ensures single instance of the content as it's migrated. Data can easily be accessed from that repository. So if you wanted to merge it with your existing backup data or merge it into an existing archive, you can do that as well. But the migration is a process that is fully integrated within the Index Engine's workflow. And once the archive is managed or migrated, or data migrated to the archive, you can manage it to support your long-term retention needs. So you can build policies, you can tag the data, search and retrieve individual files or email. You can put together retention policies and expire the data as you need to, and provide access to it with users through this visual interface, through either reporting tools or search tools to find old intellectual property, personal data, or data that is sensitive that needs to be managed based on your legal policies. So that's it. That's the workflow. There's a number of different migration project samples that we can take you through. This has a lot of detail in it, and we'd be happy to talk with you about it. But I think you need to understand there is a workflow that customers go through in terms of managing legacy tape data. So if you see this example and you look at the legacy tape footprint, this is 5,000 tapes. It's a mix of net backup tapes from LTO 2, 3, and 4. So if you do the math here, for 5,000 tapes in this environment, it's about 3.6 petabytes. So there's really a two-pass culling phase. The first pass is looking at the catalog. So by ingesting the net backup catalog, you can perform an assessment on this catalog metadata. By performing an assessment, you can say what data has value. Maybe it's only email, maybe it's only certain files or certain servers, maybe it's certain date ranges. So based on the catalog culling process, you can potentially eliminate up to 30% of the tapes. So these tapes can be past retention or incremental tapes. So if you've got weekly fulls, I can say I can eliminate, not even touch the incremental tapes. By doing this catalog analysis, you can take your 3.6 petabytes and narrow it down, in this case, to about 2.5 petabytes. So that's without touching any tapes. The second pass is actually touching these tapes. So if you've eliminated up to 30% of these tapes, you're left with a smaller footprint, about 3,500 tapes. So these tapes will be loaded into a tape library. Index Engine would scan them, eliminate duplicates from view, saying I don't want to look at any duplicate data, so don't show me the redundancy. And then you can filter it based on, in this case, only unique email and specific files for the past 3 years as a typical culling process. And that takes the 2.5 petabytes and brings it down to a significantly smaller amount of 126 terabytes. So that was a heavy cull. So now you would set up the Index Engine's infrastructure that we required to do this migration. In this case, the customer wanted to get it done in 9 months. This could be done in any time frame because the product is linearly scalable. You could add or take away servers based on the time frame that you want to manage. So these are 4 Index Engine Linux servers connected to 4 libraries, 126 terabytes of cloud storage, and that data was instantly migrated to that cloud storage, allowing them to go to a new transformed environment where they can shred the tapes because they've got everything they need for long-term retention, in this case in the cloud. They can retire the legacy tape infrastructure, significant cost savings, and then manage and access the data going forward in the cloud. So very quickly, a typical workflow for a typical migration project, so you can understand how Index Engine works and the resources required to get these projects done. So the cost savings here, and this is for this previous example, these 5,000 tape net backup environment. If you look at the different cost structure, you can see here the backup restoration infrastructure. So that includes the data center resources required. You can see here the cost required to maintain that. For in this case, this example, this 5,000 tape environment. The backup software was fairly significant here. You can see it in green. The tape storage, not very significant, usually a small piece of the puzzle here. But tape management, so this is a large component here for this customer. So they were using third-party resources to do a lot of tape restoration to support legal and eDiscovery efforts. So when you add up all these cost factors, you can see in this case here for a 5,000 tape environment where customers were going back to tape frequently, their business as usual costs were almost $300,000 US to manage that environment. So by going through the process, in this case, it was a one-time migration fee to migrate the data of value from tape to cloud. You can see the transformed environment is significantly less expensive. And it's really the cost of the cloud infrastructure, the cost of moving the data value to the cloud storage itself, and then the staffing required, which is very, very minor. But you can see really the transformation process reduced what the customer was spending upwards of about $300,000 US to manage, down to significantly less expensive, about $56,000 US to manage that same environment. So it was a cost savings, significant cost savings over 3 years to be able to manage that environment. So there's definitely an ROI and a TCO analysis that we can take you through to help you understand the data center cost savings, but it also transforms the environment to provide better access and management of this sensitive business records to support things like the GDPR regulation, personal data management, personal data regulations, and so on. So a number of different deployment options exist with Index Engines. This is the wrap-up slide. We can deploy this solution on-premise so it can manage data in-house. We also have a remote assurance program where Index Engines can remotely manage, for example, the catalog ingestion process. So that makes the migration and management of the catalog very easy. We also are working with a number of partners to build tape factories. We have a partnership with Dell EMC, Index Engines, and HCL, a global system integration organization that can really provide cost-effective solutions and a secure processing facility where tapes and libraries can be shipped to secure processing facility, and there'll be a turnkey solution to migrate the data of value from tape to the cloud. So that's the presentation. There's a number of other deeper dives that we can provide in terms of product demonstrations and more detailed overviews. If you do have questions, please reach out to Index Engines, and we would be happy to present the solution and talk to you about your specific needs. Thank you for your time. Appreciate it, and hope you found this very informative.